Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to talk about data types. Specifically, we're going to discuss the difference between strings and categories and the advantages and the disadvantages of each of these two types of data types, and when and how is it in our best interest to choose which one of them in the case of dealing with big data. Because when we have big data, we want to optimize every piece of our code. And choosing the right data type is also an important decision. And in this video, you're going to be able to understand and learn the nuances and the differences between the data types category and strings, and you're going to be able to make the best decisions in every situation once you have understood these differences. All right, let's get started. Okay, so the first thing I would like to mention here is that I have created a repository specifically for this video on GitHub, right? So under my GitHub repository, Roy Jafari, if you look at string or category, you're going to find all the codes that I'm using here in this video. You can see I've already put the pre-recording file here. So this is exactly the file that I have here that I am starting to work on, and you can see there are a lot of information already filled out here. So one of the things that might be the best thing for you is to download this file first right now, right, and try to follow along as I'm going through this. However, once I'm done with this file, which I'm going to add some stuff here as we go along, I'm going to also upload that file here. The name is going to be after recording, so you can access to what I note here as well. So you can choose which one of these two files you're going to be using. All right, so let's look at what we have here. So basically what we're going to do here, we're going to experience having the same data when we use data type string, and also when we use the Pandas data type categories to encode those data. And we're going to experience the differences when we do that. That's just going to be enough for us to know when and how, when should we choose which of these two types of categories. All right, so the first thing we're doing here, we're creating a data frame that we are randomly creating a column that is either their values are going to be either underperforming, meet expectation, and exceed expectation. We're basically creating a column of performance randomly, but we are encoding each of these values, each of these underperforming, meet expectation, and exceed expectations as a string, right? So when we create this data, we've got 1 million record, right? So we pay attention that our data type here is set as object, and also we are using about 7.6 megabyte of our memory, and that's when we encode it as a string, right? So in this second part, we're doing the same thing. However, pay attention, we are passing a data type category, right? So let's go ahead and run this code, right? So when we do this, we are basically getting the same data, right? So I can, once I did that, I can sort of kind of take a look at the data. This is basically the same data, right? It's just these values. However, now that I'm doing this, right, the amount of data, it's basically the same data, is randomly created. Look at how smaller the RAM memory is 976 kilobyte versus 7.6 megabyte, right? So right off the bat, we can see that when we use categories, we can be more economical with our memory. And the reason for this is here, right? So let's go over these two questions because we're going to answer those here. So the first question is, what is the difference between the data type of date categories and df string? We saw one is category, right? The other, it's recorded as object, right? So the question here is, weren't you expecting to see a string for df string? What's happening? Google to find the answer. So what's happening here is that for Pandas DataFrame, strings is encoded in such a way that it is also as any types of object is encoded, right? So it doesn't have a specific category that it's going to say string when you have a string, because there are different types of strings depending on the number of characters you are using. So for when you record a string, it's just going to say object, and that's basically our clue when we are sort of like keeping strings of characters. That's just going to say object. So that's what that is. Let's talk about the fourth question. What is the difference between the memory size of df category and df strings? We saw that one uses significantly more, which is using string. Which one uses significantly more, and how can you explain the big difference between the two data frame while they are essentially containing the same data? So the reason that strings uses more memory is that when you have a column that is data type string, it is designed to be expecting any types of values, right? So every character, right? So how it's going to be encoded for Pandas is going to say, okay, the maximum number of characters I'm going to get is, let's say, 20 characters, right? It is going to create a space in your computer that every one of these million rows of data for the performance is going to have enough memory to keep 20 characters, right? Each of these characters, because the way the characters are encoded, may take up as much as 4 bytes and even more, 8 bytes, however many every character needs, right? So when you have such a situation, you are going to keep a lot of data for repeating the same thing, right? So we are repeating the same 3 values again and again, and we are keeping this much of our memory, right? So that's why memory, when we are using a string, this is much higher. But with category, what's going to happen, we are going to have our 3 categories. We're going to keep these 3 in somewhere in our memory, right? We have one value of meets expectation, one value of underperforming, and one value of exceed expectation, right? So one of each of these, right? And then on all of our values in the data frame, we're going to point to one of these 3, right? We're going to say, okay, whatever it is that I have here. And pointing to a location in your memory is much cheaper as far as using memory. Pointing is just, just the address, and it does not need as much memory usage to point to that. So, all right, so let's move on to now experience how it can impact the performance of whatever we are doing with these data, right? So it says run the following code and note how long it takes for your computer to perform, right? So we're going to run this code. Basically, we are grouping by our data, right? And we are basically calculating the number of each of these types of categories. We created randomly. I mean, the answer is not what we're interested. You're interested to know how long this takes, right? So let's go ahead, do the same thing once with df category and once with df string, and see what are the differences there. So I'm going to add here and run this, and we can see when we are using string, my computer takes much longer, about 100 times, even more so longer. And this is a significant difference. I mean, we've got 1 million row and it's less than a second, even for string. But when we are doing this again and again on big data, this is a pretty big difference, 100 times faster. So we have to pay attention to the different types of data types that we are using. And yes, there is a significant difference. That's the question that is asking you here, so you can answer that. There's another advantage to using categories as your data types over a string. That it has nothing to do with the performance of your computer as far as the CPU and your memory. It has to do with more analytic capabilities that you can get with categories, right? So there's also one more thing that you could be using with categories. So here we are doing some analytics, right? And we want to see if this analytics is going to give us what we are expecting, right? So it says whenever the performance is larger than meets expectation. And we have to understand that computer doesn't understand these words, right? It doesn't understand that meet expectation is better than underperforming, and exceed expectation is better than meet expectation, right? The computer does not understand these, right? But when we do this, right, somehow magically it's giving us some result. It's saying, there are some stuff that are larger than meets expectation, right? It's greater than or equal. So equal, it makes sense. But it says meet expectation, we want things that are larger, but it's bringing us underperforming, right? So it's actually giving us a wrong answer. So what's happening here is not a wrong answer, right? What's the computer is doing is checking by the character, right? So M is before in the alphabet, before U. Therefore, U is larger than M, and that's basically what it's doing. It's saying underperforming start with U. U comes after M. Therefore, I'm going to show you underperforming as something that is larger than meet expectation, and that's incorrect, right? However, when we do the same thing using this, which is the DF category, we get an error. One would say now we have a category, we have an opportunity to maybe encode an order in this thing, right? In this relationship, right? We have these just three categories. How about we kind of like let our computer know that there is an order between these values? And that's just the way you could do it with Pandas, right? You have to do that with a specific API, Pandas API that types, right? It has a class of object category called data type, and using that you could create a category called data types that you can also make sure that you say that there is an order in them. And when you say there is an order in them, whatever order you put in the definition of your categories, which is here underperform, meet expectation, and exceed expectation, is going to be encoded in your data, right? So let's go ahead and run this and see what we are getting here, right? So this is basically creating the same data. It's a category, but there is an order in the categories, right? And we can see as far as the amount of memory usage, we are not adding much, right? It used to be about the same. Let's just go ahead and check together. 976 kilobyte is the same as 976 kilobyte. Yeah, right. So on this one, now let's go ahead and do the same code here that we did with DF category that we got an error, but here we're not going to get an error, right? It's a DFO category, which is ordered category. Now, when we say larger than meets expectation, it's actually bringing us what we expected correctly as far as the meaning of these words, which is exceed expectations is larger than means expectation is large, exceed expectation is larger than means expectation, and means expectation is the same as mean expectations, right? So that's basically another capability that you can add on when you're using categories, but you have to be intentional. You have to let Pandas know that this is what you need, which is basically an ordered category. So as kind of like a wrap up to this video, and also being able to answer this step 12, which is asking us to tell us about advantages and disadvantages between strings and categories, and also ordered categories, is that we would want to use string when we are expecting each of our values in our column would be completely different every time, right? We would use string when we are encoding a column of name and family name and address. We are expecting completely different things every time on each of these rows. But when we have a handful of the same values, it is in our best interest, of course, to use categories, because not only we are going to be using smaller amount of size of our memory, we're going to use our memory less, but also our CPU performance is going to be better. So there is no question there, right? When we have small number of possible values in a column, we have to use categories, right? But it also comes with other advantages, such as, you could be having ordered categories that it is going to allow you to be able to do analytics at higher level that you would not be able to do with strings, because there is no order between these strings, but we can create an order between these categories. In this video, we talked about the differences between strings and categories, specifically in Pandas DataFrame, and how using categories in the cases that you don't have as many possible values under your column is the right choice as your data type. And you want to be intentional when you're creating your data frames to make sure that in those situations you're using the category. All right, on to the next video.